Jackie with DMT Institute, and today we're going to talk about multiplying fractions, but more specifically, seeing a fraction as a scalar. Fraction as a scalar is one of the views of fractions, and it's one that's going to help us with some initial ideas of ratio and proportional reasoning. Throughout this video, we're really going to tie in the fraction language. So if you haven't watched Jonathan's video on the fraction definition, you're going to want to go back and watch that. I'm also going to reference some ideas from the equivalence fraction video that I did earlier. So all of those ideas are going to be embedded and might be helpful in helping you make sense of this one. All right, so we're going to start by scaling down. We're going to use the task of a race. So Frank is 1/4 of the way done with a 1/2 mile race, and we want to know how much of a mile has he run. So as you can see in the bar model, one of the first things that we're going to have to deal with or work through with kids is just the idea of one race and 1/2 mile being at the same spot on that on that bar model. And again, it's we're trying to coordinate those two units and see the relationship between a race and miles. All right, so he's 1/4 of the way done with the race. So the first thing I might do is I might partition that race, that unit of one race, into fourths. And then I can look at 1/4 of the race, which is again that green spot, and see this is how much of the race Frank has run. The problem is that I need to know how much of a mile he's run. So conveniently, I can go back to that fraction language and talk about, well, how many of these smaller units does it take to compose 1 mile, which is going to get us that unit size. So I can take a look at it would take 1, 2, 3, 4, imagining this other half partition, 5, 6, 7, 8. If it takes 8 to compose 1, it now means their name is 1/8, and I can go ahead and label those 1/8 units. All right, so I can see that my 1/4 of a race is related to 1/8 of a mile. So it lets me answer that question. Let's take a look at the algorithm though. So our algorithm is we're taking 1/4 of a half. So let's take a look at what that's doing. So I started with my unit of 1/2. That 4 in the denominator took my half, my 1/2 mile, partitioned it into fourths, or made it everything a fourth its size, which then created 4 times as many units to compose 1. It used to take 2 to compose 1, and now it takes 8, 4 times as many. However, we made those units 4 times smaller, but we didn't count any more of those. We're still only counting 1 of those units. We didn't increase the count. So we've actually taken that original amount of 1/2 and scaled it down to 1/4 its size. All right, so now let's take a look at what happens when we scale up. So for this one, we're going to take a context of cooking. So we have Eddie that's making cookies, and that calls for 1/2 cup of brown sugar. He's going to make 1 1/4 batches. So we want to know how many cups of brown sugar he's going to need. As you can see, just like in the last problem, we still have to deal with that idea of 1 batch and 1 cup being at the same spot. Again, we're looking at the relationship between batches and cups and how those two things relate together. All right, so if he's going to make 1 1/4 batches, let's just deal with batches for a minute. And I'm going to go ahead and take that and I'm going to partition it. And I'm going to show my 5/4. And of course, you could use the mixed numbers as well if you wanted to label that as 1 1/4. So I can see my 1 complete batch and 1/4 of another batch. But again, same problem that we had last time. My question is about cups of sugar, which again is that other unit that we're looking at here. Conveniently, we can use the same question of how many smaller units does it take to compose 1 cup, which lets me go back and think, okay, how many of these units does it take to get to 1 cup, which would give me 1/8. So now I can visually see that 5/4 batches relates to 5/8 of a cup. One more time looking at the algorithm. So this time again, I started with that 1/2, that relationship between 1/2 cup and 1 batch. I still partitioned everything in fourths, which made 4 times as many units to compose 1. But this time, I increased the count by 5. So instead of counting 1, I counted 5 of those units. So I made them 4 times smaller, but then counted 5 of them. So I actually scaled up the original amount. So it was at 1/2, and now I've gone beyond that. Again, because I counted more than what I scaled it down to. So hopefully that helped with just some initial ideas about thinking about multiplication as scaling. There's some practice pages that you can use if you want to take a look at this and practice some of that language and modeling. And we'll see you soon. Thank you.